Everyone, in this video we will be looking at how to calculate questions with a QSP, or with what's better known as a trial KSP. So what we're going to do is do the following 4 steps. First thing we're going to do is we're going to write a balanced chemical equation and decide, is there a precipitate that can be formed in this reaction? Step 2 is we are going to look at the dilution of the ions and see, okay, how much are these ions being diluted? How much do I need to convert them using M1V1, M2V2? Third thing we'll do is, using step 2, we'll calculate a trial KSP. We'll calculate QSP. And then what we'll do is compare the QSP to that KSP. And if we have it being bigger than the KSP, it's super saturated, so we do have a precipitate. QSP equal to KSP, we have a saturated solution. This won't happen very often, but it is possible. And then QSP, KSP unsaturated, we will have no precipitate. So here's what our question looks like. 25.0 milliliters of 0.0020 K2CO3 potassium carbonate are mixed with 75 mils of 0.000125 molarity of lead 2 nitrate. Will a precipitate form if KSP of lead 2 carbonate is 1.8 times 10 to the minus 14. This one sticks out because this one is a product that we're going to be dealing with. I'm going to just extend this page so I have as much space as I need. These questions do tend to be a little bit longer. So first thing we'll do is we'll start off with that balanced chemical equation, and we'll decide if precipitate can be formed. So we have potassium carbonate, K plus, CO3, 2 minus, and then we are reacting that with lead nitrate, so Pb 2 plus, NO3 minus, and that's reacting to produce, well, if we do the double replacement reaction, K plus, NO3 minus, and then the other product will be Pb 2 plus and CO3 2 minus. And so when we actually write all of this information down, we're going to get K2CO3. And what we assume with these questions is that we are going to be mixing 2 aqueous solutions. The idea is that we're mixing 2 aqueous solutions with the eventual goal of producing another aqueous thing and a solid. So what we need to do for this question here is, to determine the states, we need to go to that solubility chart, and we need to look and see, well, when K and NO3 are mixed together, do we form a precipitate or not? And so when we find NO3 on here, what we see is that essentially all of those guys are going to be soluble. And so what we can say then about this KNO3 is that this will be an aqueous thing. Next thing we'd look at is PbCO3. So we find the carbonate on here. Carbonate's down here at the bottom, and you can see that all others will have low solubility. So we know that this thing will form a precipitate, a solid. And what we can determine sometimes through questions is, if we get 2 aqueous things, we know no precipitate will be formed whatsoever. And so we can right away answer that question and say, hey, no precipitate's going to be formed. And so we've done step 1. We've found out that yes, in fact, we do have a solid, and it's this PbCO3 that's going to form our solid. And so the next thing that we'll want to do then is we will want to write a dissociation equation for this PbCO3. So the dissociation equation for PbCO3 solid is going to be this, where we have the Pb2 plus aqueous, and we have the CO3 2 minus that is aqueous. Now, the formatting of this is kind of strange, but we always write this solid on the reactant side, even though up here in our balanced equation, our unbalanced equation, we need to balance it like this. Down here, we'll write it just as a reactant in our dissociation equation. That's one of the nomenclature things of how you do these questions. And so what we want to do then is we want to write a trial. We want to write a trial QSP expression. Well, QSP will be the exact same. It'll always be the concentration of products divided by the concentration of the reactants, in the same way that we did KSP. And so here again, notice that we have a solid present. So what we'll do is put the concentration of Pb2 plus multiplied by the concentration of CO3 2 minus, and that'll all be over 1 since this reactant is a solid. And so what we need to do then is, in this initial question here, we were given a variety of pieces of information. Potassium carbonate, we were given 0.00200 molarity and 25.0 milliliters of it. The PbNO3, we were given a 0.000125 molarity solution and 75.0 milliliters of it. Now notice we want the concentration of the lead and we want the concentration of the carbonate, and those are added in different amounts, different concentrations and different volumes of them. And so what we need to do with step number 2 here is we need to calculate the dilution of those ions. We need to figure out how much Pb and how much CO3 do we actually have. So solving for the concentration of the Pb first, what we were given, or what we're going to use here is we're given M1V1 equal to M2V2 is what we want to eventually figure out, because this M2 will tell us how much of our concentration we will actually have here. How much of our concentration we'll actually have. And so we can start plugging in some numbers. We'll plug in the M1. What we started with was 0.000125 molarity of that Pb. And then we were also given 0.075 liters. Again, remember when we convert, we want to use liters in these questions here. Okay, so 75 milliliters converts to 0.075 liters. Now, we might get stuck at this point and say, well, we wanted to calculate the M2. We don't actually have a V2, but in fact we do. We're adding two different volumes together. We're adding the 75 milliliters from this solution here, the PbNO3, and we're adding 25 milliliters from the other solution. And so what we end up getting is 100 milliliters, which is also equal to 0.1 liters. So we actually do have our final volume. That's our V2 there. So we have 0.1 liters like such. So to solve this, we would want to get the M2 by itself. So we'll divide both sides by 0.1 by 0.1. And when we combine those numbers together, the 0.000125, multiply that by 0.075 and divide that by 0.1, we get a final answer here of 0.1234937.5 molarity is equal to the M2. And that is specifically for our purposes. That is the lead that we're talking about. That's the concentration that we get there. Okay. Next thing that we need to do then is solve for the concentration of that carbonate, CO3 2-. So we're going to use the same thing, M1V1 is equal to M2V2. And we're going to plug those other numbers in that we had up here, the 0.0020 for the initial concentration, molarity, and we had 25 milliliters of that, so 0.025 liters. Now again, we want to solve for the M2, and in this case, our V2 will be the exact same as what we had above. We're adding 25 milliliters and 75 milliliters, so our total volume there would be 100 milliliters or 0.1 liters. To solve for this question, again, we would divide by that 0.1 on both sides. And when we combine all of that information together, 0.002 times 0.025 divided by 0.1, we end up getting 0.0005 molarity is equal to the M2. So now what we have here, I'm going to put a box around this so that we can keep track of where our answers are. Right now what we've done is we've solved for these two concentrations of this QSP expression. So what I'm going to do is copy this QSP expression, and we're going to move that down here. I'm going to move that down here and then give myself some more space. So now we have those actual concentrations to plug into this equation. And so what we knew is that the concentration of Pb was this 0.0409375, 0.1234937.5 molarity. That was the concentration of the Pb. And then the concentration of the CO was the 0.0005 molarity. And that was what we solved for up here. And again, remember, we're solving for a QSP. And so when we combine those numbers together, when we combine those two numbers together, 1, 2, 3, 4, 9, 3, 7, 5, multiplied by 0.0005, we get an answer of here 4.69 times 10 to the power of -8. And so we have our QSP here. This is step number 3, using those dilutions. We solved for QSP. The last thing we want to do is compare that to KSP. So 4.69 times 10 to the -8. We want to know if that's a bigger or smaller number than that initial KSP we were given. So the initial KSP was 1.8 times 10 to the -14. So we want to know versus 1.8 times 10 to the -14, we want to know which number is bigger. And in fact, the 4.69 number is bigger, so we know that this would be supersaturated. And we also know that a precipitate will form for this particular question. So what we did throughout the process of this question was we did step 1, we wrote a balanced chemical equation here, and then we plugged in the information that we knew from this question below it. We did a dissociation equation so that we could get a QSP expression, and then we realized that we needed these two pieces of information, the concentrations of both of those. So we did M1, V1, M2, V2, and plugged in for the M1 and V1 the questions information. For V2, we plugged in the two volumes, added them together, got 100 mils. And we solved for M2. That gave us our PB concentration. We did something very similar with the CO3. And then using those two concentrations, we plugged them back into that QSP expression, solved for it, compared it to the KSP, and ended up finding out that this solution will be supersaturated and that a precipitate will form. And so that is how to solve for questions that have a trial KSP or a QSP.